All right, question one. So this is, what is this? Section 1 point, this 5? Right, 1.5, PC 20. Good. I'm frozen. There you go. Now you can see that. If anybody needs to shut those lights off to see this, you can go ahead and do that. All right, so question number one, so first part of your assignment here says state whether each infinite geometric series is convergent or divergent. So remember, convergent is when R is between -1 and 1. Okay, so it's like a decimal form of something. It can be positive or negative, but it has to be decimal something less than 1. So that's the key. Here, R is 4. That's greater than 1. That means all the numbers will be getting bigger and bigger and bigger. Okay, so that's divergent with no sum. Divergent series have no sum because you keep adding larger and larger numbers. It doesn't end up to zero in on anything or come close to anything. It just keeps getting bigger. Here we go, -1/4. There we go, that's convergent. Okay, state whether, oh, you don't have to find the sum. So this is convergent, it does have a sum. C, the numbers seem to be getting smaller. R looks to be 1/5 here, right? So this is convergent. This one, what is this here now? So this is times 2 times 2. So that's divergent. R is greater than 1. And this one here might be a little tough to figure out what R is, but let's take some of the smaller numbers that were given. And I would go -9/5 divided by +27/25, which is the same as this. And that becomes 5/1. This becomes 1/3. So we have -5/3. That's greater than 1. So R is greater than 1. And if you also look at this one, this is 243. That's 3,125 on the bottom. These are getting bigger generally. These numbers are getting smaller, which means the fractions are getting bigger. So R is definitely greater than 1. That's divergent. Any questions about 1? All right, number 2, determine the sum of each infinite geometric series if it exists. So the sum formula that you will use is right up here. So the infinite sum is taking the first term, T1, dividing by 1 minus R, as long as R is between -1 and 1. So as long as it's convergent, you can find a sum. So for A, I'll do A down here. For A, we have an infinite sum is 8/1 minus -1/4, which is 8 divided by 1 plus 1/4, or 8 divided by 5/4, or 8 times 4/5, 32/5. Okay, so that's A. Let's do D. I'm going to do D here as well, just so that you can kind of see a little different type of question. So 2D, I'm doing up here right now. T1 is 1. R is, well, 1 times what is 0.5? Looks like it's 0.5, right? So the infinite sum there of that series would be 1/1 minus 0.5. 1/0.5, and that should equal 2. That's going to be equal to 2. All right, number 3. So I'll go over number 3 here if anyone wants to watch this while you do your homework. And number 3 says, express each of the following as an infinite geometric series. Determine the sum of the series. So with this 0.87 repeating, that's like 0.87, 0.87, 0.87. So that's a series that looks like this. 0.87 plus 0.0087 plus 0.00087. Okay. So R is going to be, each time we're multiplying by 1 over, looks like 100. And T1 is 0.87, which is 87/100. So each of the following should determine the sum. So we're looking for this in fraction form. That's the whole point. So the infinite sum formula for A here, we're looking at T1/1 minus R. That's 87 over 100 divided by 1 minus 1/100th. 87 over 100 divided by 99 over 100. That's the same as multiplying 100 over 99, which is, when simplified, 87 over 99. And you may be recognizing some patterns, hopefully, with this, right? If you have one digit repeating, like 0.8 repeating like that, that's 8 over 9. There's one space that's repeating. If you have something like 0.87 repeating, that's two spaces, that's 87 over 99. So the number of nines and the number of digits repeating seems to be connected. So there's some patterns that maybe you should be noticing there. So if you had 0.127 repeating, there might be a pattern where you're going to go 127 over what? Anybody? If we have three digits repeating, how many nines would I put in the bottom? Maybe. Yeah, 3 maybe. Let's check that out. So is it just, yeah, that's math's about patterns, so it's good to recognize some patterns. 127 divided by 999. What's that going to be? Look at that, 127, 127, 127. So there are some patterns there that you can work with. Okay, I do have a separate homework video on number 5, so I'll skip number 5. And I'm going to wait till some of you have had a chance to do number 9. How many of you have attempted number 9 or have done number 9? Okay, about a third of you. Okay, I'm just going to hold off on that. I'll help you with number 9 in a bit. All right, so number 9 looks like this. It says the infinite series is given by this expression right here. And it's, okay, so it's listed here. I'll make it bigger. 1 plus 3x plus 9x squared plus 27x cubed and so on. It has a sum of 4. What is the value of x? List the 4 terms of the series. So what we're going to do is we're going to try and determine whatever we can from what we're given, right? What are we given and what do we know, or what can we figure out from what we're given? Obviously, we're going to have to use this sum formula. So s of infinity here, the sum of an infinite number of terms. I'm going to need to maybe know T1, or I'm going to find T1, and R is also involved. So let's see what I know. Well, I know what the sum is, right? It has a sum of 4, check. So I know that 4 is going to go over here in place of this term right here, this value right here. What is the value of x? Okay, so do I know what T1 is? Yeah, actually I do know what T1 is. It's just a regular old number. I know what that is. Perfect. Do I know what R is? Well, I can find R. R is going to be a little bit different, right? It's not a number. It's going to involve x, which actually is perfect because if I'm asked to solve for x, I need to generate some kind of equation that has x in it, and then I can solve for x. You see? So if you had an equation that didn't have x in it, well, you can't solve for x. If you have an equation that has multiple unknowns, like it has T1 you don't know, R you don't know, and blah, 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 then it's really tough to find x there too if you have more than one unknown. But if you have one unknown and that's the x that you're looking for, it's easy. So let me explain. R is given as any number divided by the one before it. So what's 3x over 1? Well, it looks like R is 3x. Okay. Now, this does have a sum, so this must be a convergent infinite geometric series, which means that x is going to have to be a decimal of some sort because this whole thing has to be less than 1. You with me? So it's going to have to be less than 1/3, really, right? Because 1/3 would be 1, 3 times 1/3, so it's going to be less than that. So we're going to be looking for some kind of fraction. Just you might see that and anticipate that. So if R is 3x, now I have everything I need to put into this equation so that I can start to solve for x now. And this is what it looks like. 4, I said, or we said here, was the sum. T1 is 1. R is 3x. Okay, I'm going to pause right there. That's half the question right there. Okay, that's half the question right there. More than half probably now. So are you guys okay with getting to this spot? Yeah? It's weird when R is written in terms of a variable. I get that. But you need that because now you're going to solve. Okay, so what we do now is we multiply everything, both sides, by 1 minus 3x. Why? Because I want to get rid of the x in the denominator. That's no good. You have to have x in the numerator in order to solve for it. You need to get x by itself, positive, and in the numerator. That's how we solve for variables. So over here it's a bit messy, but it's going to be 4 minus 12x when I multiply that out. And that just equals 1. Good. Let's subtract 4 from both sides. Negative 12x equals negative 3. And then over here, I'm going to divide both sides by negative 12. And x is then going to be equal negative 3 over negative 12, or just 3 over 12, which reduces to 1 over 4. So x is 1/4. Awesome. We need x to be less than 1/3, we said, in order for this to be a convergent series that has a sum. So 1/4 is less than 1/3. We're looking like we're probably getting the right answer here. Okay. So if x is 1/4, what are the first 4 terms now? Excuse me. Well, the first term, is 1. The second, maybe let me make some room for myself up here. The second is easy. It's going to be 3 times our x value that we just found, 1/4. So the second is 3/4. The third is going to be 9 times 1/4 squared, or 9 times 1 over 16. 9 over 16. 9x squared, yeah, 9 over 16. Yeah, x is, 9 over 16 is the third one. And then the fourth one, you simply put x in again. And if any of you guys have any problems with this, let me know if I've missed something or done something wrong. I'll double check in a second. But the fourth, you just look at the 1, 2, 3, fourth term right here. So that's 27, and x is 1/4, and you got to take that to the power of 3. Now, I just talked to the grade 9s last period when I taught them math, told them that they should be memorizing their squared numbers from 1 to 20. So 18 squared, 19 squared, 20 squared. They should be memorizing those. You guys should memorize those as well if you haven't yet. The cubes, you should also memorize some cubes, at least 1 to 5, maybe even go 6, 7. You should be memorizing those because you're going to run into those quite a bit. So in this case, we're going to run into 4 cubed, right? So don't need your calculator. You should know this at some point here soon. That's going to be 27 times 4 cubed then is what? It's 16 times 4, right? So 64 is right. So 4 times 10 is 40. 4 times 6 is 24. 40 and 24 is 64. All right. If you don't know that yet, that's fine. But you should write a list down there, have that on a cue card, look at it often, try and start to memorize some stuff. So that's, 1 over 64, I should say. So 27 over 64, can we reduce that? Can we divide 64 by either 3 or 9? Those are factors of 27. 3 or 9? Anybody? Let's see. Factors of 64 would be 32 and 2 and 8 and 8 and 4 and 16. Any common factors there? Oh, so maybe 27 over 64 is our simplified answer then? You think? Okay. How would you check that? Well, you got calculators. So what you could do is you could literally go 27 divided by 64, and you could find out what that is as a decimal. You probably will have fraction buttons on your calculator. So my fraction button is under the math here. So I'm going to go to fraction, number 1. And look at that. 27 over 64 is the simplest form. So your calculator can help you with simplifying as well. It's not a big deal. All right. Okay, that's pretty fast. I went through that pretty quick, but do any of you have any questions? And maybe, did anybody check these answers of mine here? Am I right? X is 1/4, 1 3/4, 9 16ths, 27 64ths. We're good. The book agrees with me, so the book is correct. Any other questions right now?